The rth term of the given series can be written as 1 upon r times r plus 1 times r plus 2. Now multiply both the numerator and denominator by 2. The numerator can be rewritten as r plus 2 minus r, and the denominator remains the same, which is 2r times r plus 1 times r plus 2. Now this general term ur can be broken into two components. The first component is half of r plus 2 divided by r times r plus 1 times r plus 2. And the second component is minus half of r divided by r times r plus 1 times r plus 2. In the first component, r plus 2 cancels, and the second component, r cancels across the numerator and denominator, and therefore ur can be written as half of, in brackets, 1 upon r times r plus 1 minus 1 upon r plus 1 times r plus 2. Now put r is equal to 1 to get the first term u1 equal to half of 1 upon 1 times 2 minus 1 upon 2 times 3. Put r is equal to 2, u2 is equal to half of 1 upon 2 times 3 minus 1 upon 3 times 4. Similarly, when r is equal to 3, u3 is equal to half of 1 upon 3 times 4 minus 1 upon 4 times 5. So on and so forth. And finally, when r is equal to n, un is equal to half of, in brackets, 1 upon n times n plus 1 minus 1 upon n plus 1 times n plus 2. Adding all of these expressions, on the left hand side we get the sum of the series to n terms, and on the right hand side we note that alternate terms cancel out and we are left with just two terms, the sum of which is equal to half of 1 upon 1 times 2 minus 1 upon n plus 1 times n plus 2. The right hand side can be simplified by taking a common denominator, which is 4 times n plus 1 times n plus 2, and in the numerator we get n plus 1 times n plus 2 minus 2. This is equal to n square plus 3n plus 2 minus 2 in the numerator, and the denominator is 4 times n plus 1 times n plus 2. The numerator simplifies, and the value of Sn is equal to n times n plus 3 divided by 4 times n plus 1 times n plus 2, which is the required answer.